Good morning, good afternoon, good evening. This is Mr. Payne bringing you Variation Within Data Sets, Unit 10, Lesson 4. Your objective for today, remember I want you to start writing down the important part of this objective in your WSQ. You will be able to identify what the interquartile range is in a set of data and explain the purpose of the interquartile range. You will also be able to use your calculator to identify the sample standard deviation and the population standard deviation. So we have a few major things today that we're going to find. By the end of this lesson, you should be able to tell me what the interquartile range is. Should also tell me what symbol the sample standard deviation uses and the population standard deviation. Measures of central tendency give us numbers that describe the typical data value in a given data set, but they do not let us know much variation there is in a data set. Two data sets can have the same mean but look radically different depending on how varied the numbers are in the set. Exercise number 1. The two data sets below each have equal means but differ in the variation within the data set. Use your calculator to determine the interquartile range of each data set. The IQR is defined as the difference between the third quartile value and the first quartile value. So that's some important information there that I'm going to underline in red. The interquartile range, also known as the IQR, is defined as the difference between the third quartile value and the first quartile value. Well, if you forget where we find my quartile values, it is in our calculator. We have to find my Q3 and my Q1. So in the first set of data, my Q3 is going to give me 9.5 minus my Q1, and my Q1 is going to give me 4.5. When I subtract them, my IQR, my interquartile range, is going to be 5. That means my box, if I was thinking about my box and whisker, from this point to this point is going to be a difference of 5. So that means my box is going to be a little bit bigger. My Q3 or my Q1 and my Q3 are a little bit farther away from my median than in data set 2. In data set number 2, my Q3 is 8 minus my Q1, which is 6. So that means my interquartile range is 2. If I were to draw a quick picture, that just means that my Q1 and my Q3 are just a little bit closer than my median is the same, but my Q1 and my Q3 are just closer to my median. The interquartile range gives a good measure of how spread out the data set is. So what is the purpose of the interquartile range? It gives you a good measure on how spread out your data is. But the best measure of variation with the set of data is standard deviation. The actual calculation of standard deviation is complex, and we will not go into it right now. We will rely on our calculators for this calculation. Using the same set of data sets above, use your calculator to produce the standard deviation shown as that symbol, and that's my sample, or that's my population standard deviation sample of the two data sets. Round your answer to the nearest 10th. If I want to find that in my calculator, it is right here. That symbol in my calculator under the same category as my variable stats is this symbol. In this case, in data set number 1, it is 2.7. In data set number 2, it's 1.4. Like we said, that data set number 2 had a smaller spread of data or variation in data, and that is proven by my standard deviation of 1.4. It is clearly smaller than 2.7. The standard deviation of a data set tells us on average how far a data point is away from the mean of the data. The larger the standard deviation, the greater variation within the data set. So let's look at exercise number 3 with no understanding that what standard deviation is. A farm is studying the weight of baby chickens, chicks after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. Find the mean, the interquartile range, and the standard deviation for this data set. Round any non-integer values to the nearest tenth. Include appropriate units in your answers. Give an interpretation of the standard deviation. So the important parts here are 20 chicks, so that when we type in my information, I make sure that I have 20 in my information. My mean, remember, is the one with the X bar on it, so my mean equals 3.7. My interquartile range is my Q3 again, minus Q1. Q3 is going to be 5, minus Q1, which is 2.5, which gives me an interquartile range, IQR, of 2.5. When I go back for my standard deviation of population, I'm looking for that symbol again. It's going to give me a standard deviation of 1.7. Remember, closer to 0 we get on my standard deviation, the less variation I have amongst my data. So this is pretty small. That's pretty good. We're going to jump to exercise number 4. A marketing company is trying to determine how much diversity there is in the age of people who drink different soft drinks. They take a sample of people and ask them which soda they prefer. For the 2 sodas, the age of those people who preferred them is given below. So what I want us to do is type in this information, and let's get some information first. My mean for soda A is going to give me 26.7. My population is 8.8. Standard deviation equals 8.8. And for the next one, my mean, I'll write it for soda B over here. My mean equals 23.4. And my population deviation, standard deviation, is 3.9. It says, explain why standard deviation is a better measure of the diversity of the age of the mean. Well, my mean doesn't tell me anything. My mean tells you my average age is 23.4, my average age is 26.7. It doesn't tell you what my variety is. Looking at my population or my standard deviation shows me that there's a greater population variation in soda A. So in soda A, explain, it says in question A, it says explain why standard deviation is better. Because it shows the diversity. Standard deviation shows the variation. In age. Larger the number, the larger the variation. So it says here, which soda appears to have the greater diversity in age, people who prefer it? Well, in this case, the larger the number is 8.8, so soda A has more diversity. C says, use your calculator to determine the sample standard deviation. Okay, sample standard deviation normally gives us S of X. So if I look back at my calculator, and S of X, soda A would be 9.1 for soda A, and soda B would be 4.1. And that still makes sense. Notice here that sample A is higher and the other population standard deviation, and standard B is smaller, and the same has a truth as well here. Population versus sample standard deviation. When we are working with every possible data point in interest, we call this population and use the population standard deviation. Population standard deviation. When we have only a sample of all possible values, we use the sample standard deviation. So they're going to tell you what deviation you want, either sample or population. The formulas of these are two different very slightly. The formulas for these two differ very slightly, so their values tend to be slightly different. Which of the following data sets would have a standard deviation population, see how they told you, closest to 0? Do this without your calculator. Explain how you arrived at your answer. Well, remember that my deviation is how wide spread out the values are. And then this one, it goes from -5 to 5. So my values are pretty spread out. If you typed in your calculator, you get a 2.9 for deviation. In choice number 2, it goes from 5 to 20, so they're very spread out. So my deviation would be even higher than 2.9. In choice 3, notice it goes from 11 to 13. It's a very small growth there. And if you type that in your calculator, you get 0.894. Do you see how it's under 1? So the closer the numbers are, the smaller the deviation. In choice 4, it goes from 3 to 18, so those are growing pretty widely. That's why it's not the correct answer. My deviation would be more than 1 there. So to sum it up, the closer your numbers are in your set of data, the smaller your deviation will be. Hope you don't have any questions, or I hope you have some questions when you come in tomorrow. Please write up a good WSQ. We will be sharing it out and seeing what you understand about standard deviation and interquartile range. Have a great evening.